This video is about a final review for spring semester. For number 1, solve the following rational inequalities. When you solve the rational inequalities, we got to use a sign diagram. First of all, we will figure out all roots and also the vertical asymptote line. So for A, roots, you will make a numerator equal to 0. So negative 11x equal to 0. You will get the x1 equal to 0. For vertical asymptote line, you will make a denominator equal to 0. Therefore, you set up 3x minus 1 and a 5x plus 4 equal to 0. Means x equal to 1 over 3 and also x equals negative 4 over 5. This is a vertical asymptote line. Then we draw number line. We have 0, 1 over 3. Then you have negative 4 over 5. For x equals to 1 over 3, that's a vertical asymptote line. Negative 4 over 5, that is a asymptote line. Then we will choose a special number. Normally we choose 0. Since 0 this time is the roots, therefore we choose 1. Then we plug 1 into the function. You will get negative 11 times 1. 3 times 1 minus 1. Then times 5 times 1 plus 4. Then we check the sign for each factor. Negative 11 times 1 is negative. 3 times 1 minus 1 is positive. 5 times 1 plus 4 is positive. Therefore, f of 1 equals a negative number. Then check the interval including this 1 has the sign is negative. Then check for each linear factor has even power or odd power. If it has odd power, means there is a change of sign about that 0. If there is a even power, then there's no sign change about their 0. Check for this rational function. We could say it's all single factor, means for each factor, the power is 1. 3x minus 1 to the first power. Therefore, there is a change of sign about their 0. The neighbor interval has a different sign, so we get positive here, negative here, positive here. We are looking for this rational function. It's less than 0, which means the interval that has a negative sign is the solution. So we have these two intervals. We can write down the solution like this. Negative 4 over 5 to 0. Union set with 1 over 3 to infinity. Now let's look at the B. Still, we need to figure out the roots. We will make a numerator. That means negative 3 minus x times x plus 2 square equal to 0. So we get the x1 equal to 3, x2 equals to negative 2. Then we will get a vertical asymptote line. Make a denominator equal to 0. So we get the x equals negative 7 over 3, x equals negative 4. This is a vertical asymptote line. Then we draw a number line. We have -4, -7/3, -2, then 3. Vertical asymptote line is -7/3 and a -4. Then we will choose a number. This time we can choose 0. 0 is between -2 to 3. Then we plug 0 to this function. F of 0 equals negative sign 3 minus 0. 0 plus 2 squared. 3 times 0 plus 7. 0 plus 4. For each factor, let's check the sign. Here's negative sign, positive. 0 plus 2 squared is positive. 3 times 0 plus 7 is positive. 0 plus 4 is positive, which means f of 0 is negative number. So the interval including 0, we will put negative sign here. Then check for each 0 or vertical asymptote line. We need to check for each linear factor has odd power or is even power. For this 3, that's 3 minus x. That's odd power single factor, so we change the sign. This is positive. For -2, we have even power, means sign stay the same. -7/3, this is the factor. That's a single factor, so we change the sign. -4, x plus 4, still single factor, so we change the sign. We're still looking for less than 0. Therefore, this is the solution. So we write down the solution like this, from -infinity to -4. Union set with -7/3 to -2. Union set with -2 to 3. For number 2, solve the following equation. First of all, for this equation, it has a denominator. So get rid of this denominator first. We multiply by 4. So we reduce. You will get 11e to the x power minus 7. E to the negative x, I change into positive exponents. That is 1/e to the x power equals to 4. Then we have another denominator, e to the x power. Therefore, we multiply by e to the x power for every single term in this equation. So we multiply by e to the x power. E to the x power, then e to the x power. Still need to reduce. You will get 11 e to the x power squared minus 7 equals 4 times e to the x power. We could say this equation is a quadratic pattern because we have e to the x power squared. For quadratic pattern, keywords is equal to 0, so we move. 4 times e to the x power to the left side, I will get equal 0. You get 11 e to the x power squared minus 4 e to the x power, then minus 7 equal to 0. Assume e to the x power equals a. Therefore, we get 11a squared minus 4a minus 7 equal to 0. So we do ninja x. We have 11 times negative 7, that's negative 77, over 11 over 11. This is negative 4. So we get 11, negative 11, 7. Reduce, you will get negative 1 over 1. Therefore, we factor, this part is a, here's a. Bottom up, a minus 1 times 11a plus 7 equal to 0. So we get the a1 equals to 1 and a2 equals to negative 7 over 11. Then we need to plug e to the x power back into this solution. So we get the e to the x power equals 1, x equal to 0. E to the x power equals negative 7 over 11. E to the x power never be negative, so here's a no solution. Only solution will be x equal to 0. For number 3, solve the following equations. This is a logarithm equation. For logarithm equation, you need to check all logs in the equation. If yes, then just condensing both sides, then using this formula to get the solution. If no, you need to isolate the log on one side, then using this circle form, you change log into exponential function to solve x. So for a, it's not all log. We have 1 over 2. Therefore, you need to isolate the log on one side. Move this log to the left side. Therefore, we get log base 49 of x minus log base 49 of 2x minus 6 equal to 1 over 2. Then you need to condensing the log on the left side. We have log base 49 of x over 2x minus 6. While you condensing the log, here's the formula. Subtraction of the log, you got to do the division of argument. So we do x over 2x minus 6 equals to 1 over 2. Then you need to change this log into exponential form. So we do this circle. 49 to the 1/2 power equals x over 2x minus 6. You will get 7 equals x over 2x minus 6. Then we have over 1 cross multiply. 7 times 2x, that's 14x. 7 times negative 6, that's minus 42 equals x. So we solve this linear function. Subtract the x both sides. You will get the 13x equals 42. Divided by 13 both sides. You will get the x equals 42 over 13. Now you need to check whether this solution is an extraneous solution. Therefore, just check the argument. We have two arguments for this equation. We have x we have 2x minus 6. 42 over 13, we plug in. Make sure it's a positive. If it's a positive, we put the check. 42 over 13 times 2 minus 6. It's a positive. Therefore, x equals 42 over 13 is the solution. Now let's go to B. For this logarithm equation, still we need to check all logs. No. So isolate the log on one side. Move natural log of 17 to the left side. We get natural log of x plus natural log of 17 equals to 5. Then condensing the log on one side. This is the formula for condensing the log. So we got natural log x times 17 equals 5. Then change this logarithm function into exponential form. Base is e for natural log. So we get e to the 5th power equals 17 times x. Then we divide by 17. You get the x equals e to the 5th power over 17. Then you need to check whether this solution is an extraneous solution. You have argument is x. So we plug in e to the 5th power over 17. You know this is a positive. Therefore, this is the solution to B. Now let's go to C. It's a still logarithm equation. All logs, yes. So condensing both sides. Then make argument equal to each other. So for C, first of all, we need to condensing the log both sides. If we have number before log, like this 1/2, you need to jump at the exponent. That's 16 to the 1/2 power. We know that's equals to 4. Now, on the left side, we got the log base 5 of adding. That means we do multiplication. 4 times 1 over 4 times 50 equals log base 5. Adding, that means we multiply by the argument. You have 2x times x. Then we simplify log base 5. Reduce, you got the 50 equals log base 5 2x squared. Since the base is the same, we can get the argument equal to each other. So we get 50 equals 2x squared. Divided by 2 both sides because this is a power pattern equation. Get the x squared equals 25. Square to both sides, x equals plus or minus 5. Then you need to check for the extraneous solution. For argument, we have 2x and x. Solution, -5 and 5. Plug in, make sure it's a positive. 2 times -5, -10 is negative. That's why -5 is not the solution. For this 5, we plug in. 2 times 5 is positive. 5 is a positive. Therefore, the solution is x equals to 5. Now let's go to D. For the D, first of all, we check Are they all logs in this equation? Yes, so condensing the log both sides. If we have number before the log, jump at the exponent. So we got cubic root of 125. We know that is 5. Then condensing the log on the left side, we got the log base 7. This part is 5. When you're condensing, adding means multiplication. Subtraction means division. Therefore, we have a division line. 5 and 9 go to denominator. Top, you got the 5. Right side, log base 7. We got to do multiplication. 3x times 8x squared. Then reduce. Left side, we got the log base 7 of 1 over 9 equals log base 7 of 24x to the third power. Then we will make a argument equal to each other because of this formula. Therefore, we get 1 over 9 equals 24x to the third power. Since this is a power equation, we need to divide by 24 both sides. Drop down. You will get the x to the third power 1 over 9 times 24. So we get the x third power equals 1 over 216. We do the cubic root both sides. Then you get the x equals 1 over 6. You need to check for extraneous solution. For argument for this equation, we have 3x and 8x squared. We plug in 1 over 6. Make sure argument is positive. If positive, we put a check. 8x squared is check 2. Therefore, x equals 1 over 6 is the solution to this D.